And welcome back. We are going to continue our review. Today, we're going to dive right into exception handling. So the first thing we need to remember is that when we're dealing with exception handling, that we have this mechanism known as try-catch. Try-catch, of course, is a basic structure that is in Java that allows us to find different things that are going to otherwise terminate a program. The try, of course, is the code that is potentially going to have that exception thrown, whereas the catch is going to the code that's going to handle that exception. So the try is what we would normally do for our coding, but the catch is how we handle whatever errors get thrown. Now the general exceptions are structured with the following. You have a try block with some code in it, and then a catch block with some code in it. And notice with the catch block, we have this parameter here. So we have an exception E here. Of course, you can throw other exceptions, but this is just an example. This is just the general exception right here. But it's generally going to follow this format, a try followed by a catch, and of course code in between both of those. Now we can have very specific exceptions that we might throw. So for example, we have specific errors, like if we're using the scanner class and let's say we were like, hey, I wanted to get keyboard.nextInt. But let's just say the user decides to be smart and they type in a letter because they're like, hey, look at this. I'm going to try to break your program. And they type the letter A. Well, if the computer is expecting you to have an integer, but you pass in a character instead, you're going to get an input mismatch exception. Now, you could handle this very easily by just doing catch, input mismatch exception, E, and of course having whatever code you need to handle that exception. Now, any code that can be placed within those curly brackets of the catch statement, though typically this is going to be something such as like a print line message or a system.exit, or maybe you'll have some sort of thing that's going to have the program run again from a certain point. So these are all different things that you can do in order to help handle these exceptions. Now, we, of course, can throw exceptions ourselves. The program can throw it, when it encounters an error, but you can also code those exceptions in. And that's done using the throw command. Pretty self-explanatory. You want to throw an exception? Use the throw command. For example, in the throw statement, throw new exception, input must be positive, it would be caught by the appropriate catch block. In this case, it's probably just going to be a general catch exception E, which acts as a general kind of string message for our constructor because it's going to say input must be positive. That's what's going to be passed in by this exception. Now, there are other exception classes that we can use. We've already looked at a few, but obviously the more libraries that we bring in besides scanner, the more exceptions that we may have to handle and encounter for. So some other exceptions that you may handle with catch blocks include IO exceptions, which are generally going to handle your IO errors. There are obviously more specific ones you can get into. A no such method exception. So this is used to handle methods that don't exist but may be called. This happens a lot when you start looking at larger blocks of code and maybe you're using multiple classes and a method might exist in one class but it doesn't exist in another. This is a way to help handle that. And of course the file not found exception, which we of course have seen to a degree when we looked at file IO, because this handles errors related to file processing. If it can't find that file or the file is corrupted where it can't open it, the file not found exception is going to be a great way to help handle that. Now remember, you can have more than one exception in your code, but the catch, which is using exception E, is again just a general exception and should be included in your catches. So you can have a whole bunch of different ones, but this is another way to think about this, like when we did our if-else statements, our conditionals. All right, when we do an else, it's technically not required, and you may not need it, but it does act as kind of a nice catch-all, a nice little bucket that will help catch those different scenarios that you may not have anticipated. And you can do something as simple as have a print line statement that's going to give you some kind of error so that way you know, hey, here's where this program broke. Now we of course can also define our own exception classes, and we've done this before in our previous course, such as the division by zero exception, which of course, just, hey, we divided by zero, we're going to throw in an error here. Now, these classes should extend the base class exception and are called similar to any other exception. Just like we saw the generalized exception, how that got thrown, we can do the same thing here with like division by zero. Now, we can use exceptions within methods themselves. So if we want to throw an exception in a method, we can do that. We could just use the throw command. All right, we just have to make sure we use the appropriate throws method to the header. So we have to make sure, like, hey, this method throws an exception. So for example, we could say like public static double safe divide in top bottom throws a division by 0 exception. So that is a method that's going to handle that rather than me putting that throws into my main code, which can be really helpful, especially if it's going to be a method that you're going to use a lot. You can just then call that method invocation rather than having to write again and again and again those different pieces. Now, of course, you can also put multiple exceptions to a method in this way, because if you have a method that maybe is going to throw more than one exception, this can be really helpful rather than trying to, again, use that individual line of coding to get what you want. Now, just remember that if a method throws an exception that isn't caught within the method invocation will end immediately. So if you don't catch that, it's just going to terminate out of that method and then kind of proceed on. All right, and of course, we can't talk about exceptions without talking about the finally blocks. So finally is something you may not use as much, but they do come in handy every once in a while. If you have some code that you want to be executed after a try-catch block, we can use finally to run the code regardless of whether or not an exception was either thrown or caught. So, of course, bearing out that your program completely terminates and crashes, the finally is a real nice way. It's like, hey, I'm going to try this set of code. If it works, great. If it doesn't, that's why I have this finally block, because the finally is going to be the last thing that your program is going to attempt to do within a try-catch. So remember, it'll be try, catch, and then finally, always in that order. Now, of course, the try block, again, it's going to first run to the end. And so wherever the start of your code is, going all the way in. And if you don't throw an exception, great. Now let's move on. The finally block will then be executed after your try block is completed. Now, if an exception is thrown in that try block and is caught in one of the catch blocks instead, well, in this case, your final block is going to be executed after the catch block has finished. And if the exception is thrown in the try block, but you don't have a matching catch block to kind of handle that exception, well, again, the method invocation is going to end. So whether it's your main method, a user-defined method, whatever. And what's going to happen then is the exception object is then going to be thrown into the enclosing method. However, the key thing to remember here is that the final block is going to still be executed before that method ends. And let's go ahead and see how this works over here in Eclipse. And one of the things is, first we have to look at our division by 0 exception here that we've used previously. And so the key thing to remember is that this is an extend. So whenever we make our own exceptions, we want to extend the general exception class. And then, of course, we can create a constructor here. This is just a no-R constructor. This is a parameterized one that's just going to take in a string message and just returns the super call for message. This one's just, of course, returning the string division by 0. And if we go and look at our class, this is the bigger thing of how to remember things. So the first, of course, is our try-catch here that is going to throw using, in the main, just an if statement here. So this is just throwing a line by ourselves. So we just say if the denominator equals 0, throw a new division by 0 exception. So this is the first way that we had talked about. Now, of course, all the rest of this is pretty much how we expected to operate. And of course, you'll see we have our catch right here, which actually passes in that division by 0 exception. If I didn't have this division by 0 exception here, obviously then the program would complain about the try block not being caught by anything. All right, it's not like an if statement. You can't just have try here and then expect it to work. You need to have try and catch. Now, if we go to the second one, you'll see this is where it is handled by a method. All right, and in here, when we look at this one, we are using a try block, again, just like we did. However, when we go to actually get this quotient, unlike last time where we used a if denominator equals 0, and then we just called it here, we instead created a method called safe divide that then handled how that works. And of course, you can see we have our method. If we go down here to safe divide, we can see that it throws a division by 0 exception. And when it throws that division by 0 exception, one of the things you'll notice is that here's that if statement that we saw previously, which of course is the exact same if statement as what we have up here. The difference is that this is handled by the method. And again, this gives us some really powerful things. Like this is a pretty simple example, but we could of course have multiple throw statements up here that could potentially be linked to this, or we could have more code. Again, it's a way to simplify our program so we don't have to write throw new exception every time that we're going to encounter it.